Okay, this is a recap of Friday's lecture in functions trig on synthetic long division. And why do we do this? It's much quicker than using regular long division. And remember that long division is just going to be a tool for us to find factors. Now, before we do long division by synthetic, our divisor, in other words, one of the factors we're looking for, has to be this simple binomial, x minus some sort of constant. No coefficient in front of the x, no exponent on the x. Okay, if you want some more detailed steps on how to do this, it's in your textbook on page 369, and actually your textbook does a very good job of showing you this process. So if this doesn't make a lot of sense to you, go and look through your textbook, and it has some very good example problems. All right, let's do this one. All right, now the first thing we need to do is check and make sure our divisor indeed fits the x minus c. And it does, and then our dividend is in descending order, but we're going to need some placeholders. Now, a lot of people say, okay, well, what do I do? C is negative 2. A lot of people just say, I'm just going to take that constant and change its sign. If that's what you're doing, fine. That will work. I'm not going to try to make you do any weird stuff. Okay, so I need a placeholder for my x squared. Now, I've written lightly here. This is a little habit that I get into. This helps me keep track of my coefficients. And when I get my quotient, this is going to be kind of helpful. And we'll see that when we get to the end. Okay, the first thing we do is bring down this first coefficient. We multiply it by the 2, and then we put the product over here. And then we do an addition step, right? We sum those two together, and then we just repeat. And here we have a remainder of 44. And basically, our problem is done. Now, when we do synthetic division, our answer is in the form of a coefficients of the answer. So we need to fill in the variables. And I start with x squared because I know it's going to be 1 degree lower. So this is actually the entire problem written out correctly. Here's the divisor, the dividend, the quotient, the remainder. And this did not go in without a remainder, so we can say that it is not a factor of our original polynomial. Okay, so we also learned about this thing called the remainder theorem, and we're all bummed out because our factor did not divide in evenly, but I can get some information from this remainder. And this is the theorem. And it's all about that little constant c in our divisor. And basically says if I take that constant c and put it into our original equation, it should equal the remainder. So what does that mean for us? Well, we got this equation, we divided by x plus 2, and we did get a remainder of 44. So here's our important numbers. All right, c is equal negative 2. That's what we're going to plug into our original function. And then when I evaluate that function at negative 2, I should get my remainder 44. And then we put this in, and let's check it out and see if it happens. There is my value, or my constant of my divisor, into the original equation. I do the algebra, and it does check out. It's 44. So what we learn here is we actually have an ordered pair that we can use in a graph. Okay, in class we did checkpoint number 5. Here C is going to be -4. Take that -4, plug it back into our original equation, and kind of verify the remainder factor theorem. Okay, there's my setup, there's my synthetic division, and I did get a remainder. So the remainder theorem says if I stick in -4 into my original equation and evaluate it, it will equal my remainder, and sure it does. So we have a point on our graph, -4, -105. And there's your homework due Monday, and I hope this is helpful to you.